Hello, today I would like to talk about the development of analytical techniques using metabolomics. We are focusing on developing cutting-edge metabolomics technologies. In metabolomics, after samples are collected, metabolites are analyzed by the method, such as liquid chromatography, mass spectrometry, and then the multivariate analysis will be performed for the result. In this scheme, therefore, the analytical method and its development are necessary to obtain more convenient and precise metabolomics data. I would like to introduce the three analytical methods developed in our lab. First, I would like to talk about LCMS-based enantioselective amino acid analysis. First, I would like to talk about development of enantioselective amino acid analytical method. The presence of D amino acids had not been considered in the functional study of amino acids for a long time, because most nationally abundant amino acids are L forms. Recently, however, it has been reported that D amino acids are involved in higher organisms thanks to the progress of analytical techniques. The function has been paid attention in various fields such as medical and food. In recent years, the relationship between D amino acids and disease such as schizophrenia and ALS, and the difference between taste and L amino acid has been studied. Indirect methods were frequently used for simultaneous analysis of amino acid enantiomers, because direct methods were technically difficult. However, indirect method had many disadvantages in stability of derivatives, separation with impurities, and throughput. Hence, we have developed a novel direct method for amino acid enantiomers. The method enables the simultaneous analysis of 18 pairs of proteogenic amino acid enantiomers without derivatization within 10 minutes by liquid chromatography mass spectrometry on a chiral crown ethyl stationary phase. On the other hand, the secondary amine such as proline can be analyzed using a column within synchron alkaloid as a chiral selector. Here are the results of the method. The use of two analytical systems enabled an enantioselective analysis of proteogenic amino acids. As shown here, currently, some papers about this analysis method have been published by the Fukusaki lab. We believe that high-resolution metabolomics data distinguishing enantiomers could contribute to the precise functional analysis of metabolites. Next, I would like to talk about GCMS-based metabolomics by using solid phase derivatization. GCMS is the first choice of analytical method in metabolomics due to separability, repeatability, and easy automation of data analysis. However, there are many problems that derivatization process might produce large errors in conventional method, which is manually operated. We developed a derivatization method using solid phase. With the solid phase derivatization method, the process of sample loading, washing, dehydration, and derivatization can be completed in about 3 minutes. Moreover, solid phase analytical derivatization method will enable automation of sample pretreatment, which normalizes the derivatization reaction time. Therefore, more accurate analysis can be performed by this method. Currently, a paper about this method has been published by Fukusaki lab. Finally, I will talk about GCMS-based metabolomics of volatile compound method. In metabolomics research, the explanatory variables represent the metabolites obtained from comprehensive analysis using LCMS or GCMS. The response variable represents the variable that we want to predict using the metabolite profile. For example, the score of the taste obtained by sensory evaluation. Then, using multivariate analysis, we have constructed a prediction model by analyzing the correlation between the explanatory variables and the response variable. Then, Previous metabolomics research has focused on hydrophilic components. But in order to obtain more informative explanatory variables, it will be necessary to include volatile compound in the target. Volatile compounds are found in our daily lives, such as in food, exhaled air, and exhaust gas from culture media. Therefore, since volatile components may also be correlated with numerous physiological phenomena, we need a comprehensive and simple method to analyze volatile components in various biosamples. As a strategy, we decided to use GCMS, which is capable of analyzing volatile components, and to consider methods for collection, extraction, and concentration of the components. The following is an example of an extraction method for volatile components. The solid phase microextraction method is a solvent-saving and simple method for component extraction. It uses fibers coated with polymers and adsorbents. The SPME from which the components are extracted is inserted directly into the GC, and the components are introduced into the GCMS by thermal desorption. There are two types in SPME methods. One is to extract the component in the headspace between the buyer and the sample, and the other is to immerse the fiber directly into the sample. We analyzed the volatile component of 4 types of chocolate using the SPME method. Based on the results, a principal component analysis was performed. The left figure showed high reproducibility of the analysis. In the right figure, fatty acid, esters, and alcohols were found in large quantities in chocolate from region C. Furthermore, pyrazines were found to be abundant in chocolate from production area A. This suggests that these ingredients may be involved in the composition of the characteristic flavors of chocolate from different cocoa-producing regions. Next, we will talk about an example of the application of sake using SPME method. In the case of sake using SPME method, the fatty acid contained in sake have an adverse effect on the analysis, making it difficult to comprehensively analyze the aroma component. In order to solve this problem, we adjusted the pH and studied the appropriate extraction condition to reduce the large tailing peaks of fatty acid and to enable the analysis of other co-eluting components. In the future, we plan to conduct metabolomics research, including volatile component profile, using this analytical method. Thank you for watching.